Giving you today is dedicated to Steve Irwin, and in keeping with that tradition, I look somewhat different when I do this talk. I am wearing the Australia Zoo shirt. It is, in my opinion, the finest zoo in the world. It is still run by the Irwins. And of course, he's well known for one particular thing, which we're about to demonstrate to you in case you don't know what he's famous for. Terry, let me save you, Terry. Down, that's it, you stay there. I've trained that crocodile to stay. Crikey! Pointers in my... Pointers in my... Welcome to Extreme Life. And as I said, dedicated to a great naturalist who unfortunately is no longer with us. Seems appropriate. And I was there at the Australia Zoo. I spent 2 full days there. Not enough time. If you really want to do it properly, it'll cost you money. 4 days. You need 4 days to do everything there. What a place. Steve Irwin Day, as I said, is tomorrow. November the 15th was chosen because it was Harriet's birthday. Harriet is shown over on the right. She lived to 175 years of age, and of course is no longer with us. But of course, tomorrow, if you want to celebrate Steve Irwin Day, wear khaki. Expect to see a lot of khaki tomorrow. Come with me, I want to share it with you. Come with me, share my wildlife with me. This is just such a special moment. This is what I want to share with you. What I want to do is show you the beauty of this animal. I'm going to have to be so careful here. See the did you see it? Oh, he's not. I've been because I feel so passionate about all of our wildlife. I'm on top of the world, I'm gonna push it to the limit. I get to do the wildest things in the world. I'm gonna push it to the limit. You need to come with me, I wanna share it with you. So come with me as you look at Extreme Life. This picture is very controversial. Steve with his child under his arm, feeding a crocodile. And the reason is that's what his father did to him. That's how he grew up. So to him, it was very natural, although he received a lot of criticism for it. All right, what's life? This summarizes life. I'm not going to spend a great deal of time on this slide. Like most of the slides, I go through them pretty quickly. But there are things that we have that we're not quite sure if they're alive or not, such as viruses, viroids, prions. Life has many different outcomes, and you'll see as we go through this, life in different places on our planet is very different from what you think of as life. That's why we're calling it Extreme Life. So the first decision in taxonomy is to decide whether it's alive or not. And if it is, it becomes into the life domain, and then we go further down specifying how it's related to other creatures until we get down to the species, and then we've got the single animal. And sometimes we have subspecies underneath that. So that's the way taxonomy is set up. Once upon a time, we didn't have any oxygen on the planet. It was a very nasty place to be. This graph shows you the buildup of oxygen as a function of time in billions of years, the Cambrian explosion, is over here, that Cambrian explosion where life basically exploded. And what gave us the oxygen in the beginning is bacteria that managed to process other things and excrete, yes, excrete oxygen, and that's how oxygen was produced. Don't take oxygen for granted. It could go away. Some things do not need oxygen. They're called anaerobic. They live in conditions where there is no oxygen. And one of them was discovered in 1983 in the Mediterranean. It's shown here. It's only 1 millimeter big. And actually, it's so unique, they created a new phylum for it. So another complete branch in the taxonomy. It exists without light, without oxygen. Hydrothermal vents, you may have heard about these before. They're underneath the ocean. We've got hot water coming out. It's being heated by the internal heat of the earth. Minerals come out of this. There's no light down there because they're deep, yet life is around there. The black smokers were first discovered in 1979. And what we find down there are tube worms. We find clams, limpet, shrimp, and other life too. I'll give you some examples as we go along. Sometimes they use hydrogen sulfide to power the metabolic process that they need to live. Others use oxygen and others don't. It just depends. And you see some of the anaerobic life on here. The shrimp live very close to a very hot output. They can tolerate up to 35 degrees. They can't tolerate the water that's coming out of the vent, which is up to almost 400 degrees. It's completely dark there. They're blind. And yet they live around this. These are the giant tube worms, also discovered not so long ago, 1977. And that might be the earliest form of metabolism we had on the Earth. This may be the beginning. We're looking at the beginning of how life originated. Down at the bottom in the table here, you see how the metabolism is driven: photosynthesis, chemosynthesis, or heterotrophy. That uses organic compounds. It needs an organic source, and that is us, animals, fungi, protists. Underwater, just to digress to insects now, insects have adapted to be able to live underwater. And these are some of the adaptations that they've developed, and we'll go through a few examples. In the bottom picture, you see the breathing tube of that insect is actually longer than the body. So the breathing tube comes up like a snorkel, and they can breathe while they're underwater. This is the diving bell spider. It's not very big, and what it does is it brings a bubble of water down, and it stores a bubble of air down. It stores this bubble underwater. It will refresh that with air from above, and it doesn't need to surface more than once a day. So it lives totally underwater by using its own air source that it's stored. This is the Australian underwater beetle. There are many species of this, and this can absorb oxygen directly through the skin into the body. So no gills, blind, although one of them had a negative phototaxis, meaning it moved away from light, so it could detect light in some way. Very small, and that's what they look like down below. This is the climbing perch. It's a labyrinth fish. It has a special organ that can extract oxygen from the air and allows it to live outside of the water for as long as 6 to 10 days. It's not unique in this respect. There are others. And as I say, they have a special, not lungs, it's a special organ that does this and takes the oxygen out of the air. But they still need to go back into water. They can't stay out forever. What about flight now? Let's look up into the sky. This is the common swift. Using sensors, we've been able to find out how they fly around. And we find out that they almost never touch ground. They travel huge distances before they touch ground. And the only reason they come down to the ground is to basically reproduce. The eggs are laid. They obviously have to feed the chicks. And then they're off again, and they're flying around basically for the rest of their time until they reproduce yet again. But how about the Arctic tern? Their migration is shown over here, up from the Farne Islands all the way down into the southern section of the earth down to Antarctica, that region down there, and they will travel 97,000 kilometers in the migration. They will fly about 3 million kilometers during their lifetime. Unimaginable distance, for us anyway. The hummingbirds, we all know about hummingbirds. I hope the only birds that can hover, a true hover. They can even fly backwards. But there are some other birds that can do it too. Some of the prey birds, like the harrier, raptors, they can hover for short periods. And pigeons, despite the fact that some of us think pigeons are rats with wings, can do some amazing things. You know, my wife is one of those that doesn't think much about pigeons. I'm English, so I like pigeons because there's pigeon pie. This is the Birmingham roller. This is how the Birmingham roller can fly. It's a competition bird. And you can see why it's called the Birmingham roller, because it does. There's about 10,000 breeders that go in for these competitions. And away we go. Over on the right, we have the parlor roller. It's another pigeon, but it rolls on the ground. So it doesn't do it in the air. So that comes right down on the ground, doesn't roll it. Now you'll look at pigeons in a different way, right? Kick one, see if it goes up and rolls. Or maybe it'll roll on the ground when you do that. All right, let's look at size. Size matters. Some of you in this audience will agree with that. That took a while. Okay, good. At least some of us are awake. This slide used to say something different. This slide used to say up for the sea, the largest mammal ever was the blue whale. This is no longer true as of this year. We now have a new creature which is extinct. I'll show it to you in a second. That is a bigger mammal than the blue whale. And of course, the blue whale is the biggest mammal today. And cast your eyes down there. We'll go through all of these examples as we go through. They are examples of the biggest member of that group. This is Pericetus colossus, shorter than the blue whale that was discovered in fossil form, but much, much heavier. As much as 375 tons, which is hugely bigger than the blue whale. It's about double. And you see a picture of what we think it may have looked like over on the right. The paper that discovered it is shown over on the left. Well, what about the blue whale? The blue whale is there, up to 200 tons, 32 meters in length, compared to the humpback whale, compared to the great white shark. And you see down the bottom that a blue whale is equivalent to about 40 elephants. So yes, they are absolutely huge. It is a myth that the blue whale heart is the same as a Volkswagen Beetle. No, it's not. The Volkswagen Beetle is actually bigger. But this picture is a reconstruction of a blue whale heart, and you can see just how big it really is. A huge animal. This is Argentinosaurus, the largest land mammal that we know of from fossils. It's extinct now, up to about 35 meters in length and weighing up to 100 tons, about half the weight of the blue whale, but of course it was trying to walk around on the land. The largest bird here is shown in the middle, the elephant bird. Over to the left we got something that looks like birds, but they're not. They're dinosaurs. They didn't have feathers. Those two didn't have feathers on the left. So the biggest one is the elephant bird in the middle. That's of course extinct, has been since the 17th century, but could have been 3 meters high. That's much bigger than me. High bird. This is the Quetzalcoatlus. There is a full-size model shown over here. You can see how big it is. Extinct for 66 million years, 5 meters in height, taller than the ceiling in this room. A wingspan of 11 meters, up to 11 meters. Once it was airborne, it would flap occasionally, mostly a glider for a creature this big. And over on the right, you see a comparison of it with the pterodonum. They're much bigger. The humongous fungus is still alive today. You'll find it in Oregon. There's a map over there showing you Oregon. This is where it's located in Oregon. It's mostly underground, just over 2,300 acres in size. It feeds off tree roots, and you see an example of a piece of it that's sticking up over on the right. It looks like a patch of mushrooms. It's a fungus. So that is the largest living creature on the surface of the earth. The longest, however, is this one, Apolemia, discovered not very long ago, 47 meters in length. It is a collection of creatures that are cooperating together, and they are so specialized. Some of them do the digestion, and some of them do other bodily functions, despite the fact that it is a cooperative of different zoophytes. By comparison, the blue whale is only 30 meters long, so it's longer than a blue whale in the sea. What's the smallest now? Well, I've given you a list, and we'll go through this list of what the smallest creatures are. And you can see in the palm of the hand up there some very small ones. Don't be confused by the pygmy elephants there, they're not really small. This is the bumblebee bat on the end of someone's finger. You find them just in a very small portion down here in the Far East. They only weigh a couple of grams. Also discovered not that long ago, 1974. The chameleon. This is found in Madagascar. Brookesia nana, only up to a couple of centimeters in length. This was the smallest reptile. But in 2021, what happened? We found a smaller one. It's this one, and you can see on the end of the finger, again, tiny, tiny little chameleon. And in a very small area of Madagascar, threatened, of course, by expansion of human activities. The smallest frog is shown over on the left. It's found in Papua, New Guinea, only 7 millimeters long. You see an example of it on a coin in the bottom right there. They can jump about 30 times their body length, which sounds impressive, except their body length is really short, so it's not so good after all. It's one of the smallest vertebrates that we know about. This is the bee hummingbird. Again, see the size compared to the fingers there. Only weighs a couple of grams, up to 6 centimeters. It's got the fastest wing beat of any hummingbird, 200 beats per second. Other hummingbirds are much less, down as low as 43 beats per second. So this one's a real record holder. And of course, to expend that amount of energy, it has to basically continually eat all day long to be able to get the nutrients to do what it has to do. This is a fish found in Indonesia. It's endemic to this area, Sumatra and Bintan. It's also one of the smallest vertebrates in the world. Most of these are relatively recent discoveries, this one in 2005, and as you can see on this one, the body is mostly translucent. You can almost miss it in the water. Then we have duckweeds. Each speck that you see there is an individual flowering plant on the finger. And down in this picture over here, there's 2 types of duckweeds. I've given the names down below. About 40% of it is protein, so it is actually good to eat. It could be a replacement, a protein food. Then we have the nanobe. Well, the jury's out on this, whether this is actually alive or not. This is an electron microscope of these things. They're about the 10th size of the smallest bacteria, so they are really very small indeed. 20 nanometers in length, 10 to the minus 8 meters. Much, much smaller than a human hair. Smaller than anything you can possibly relate to in normal life. And of course, to do an electron microscope picture of it, you know it's small. Well, we don't know whether it's alive or not, so this one is controversial. Then we've got small bacteria. These two are very small. They're about the size of viruses. This particular group of bacteria, of which there are 125 species that have been identified, have no cell walls, which is very unusual. They have no cell walls as another mechanism for keeping all of the stuff together in those, and I've given you the sizes on there. Some of them are not beneficial to you. They cause health problems, as listed up there, one of them being pneumonia, cancer promotion. In other words, if you have cancer, it'll make it worse, or it'll even begin the cancer. That's what cancer promotion means. Now let's go the other way. Let's go down, go into the deep part of the world, and of course the deepest part is the Mariana Trench, shown here. And what's depicted on this slide is things that would be at the bottom of the Mariana Trench and how far up they would come to the surface of the ocean. And even a commercial airline is flying underneath the sea relative to the bottom of the Mariana Trench. So how deep is it? Well, it's very deep. That's why it's called the deepest place. Challenger Deep is the deepest point in the Mariana Trench. That's there. It's called Challenger Deep because it was discovered by HMS Challenger, which is shown over on the left. The only thing that remains of HMS Challenger is the figurehead in the middle of that slide. The pressure down there, it's almost 11 kilometers below the surface of the Earth. The pressure there is 1,000 times what you're experiencing sitting here. Splat. It's what happens to you if you go down there. And if you came to the Titanic, you got an idea of what happens when you implode. Well, up to 4 kilometers down, we find the Dumbo octopus, as shown here. It's named after the Disney character. This is how he gets his name, the Dumbo octopus. They can be quite large. They can be up to almost 2 meters in length. In other words, they're as big as me. And most of them are much smaller, will be about 30, 40 centimeters, but they can exist way down under this deep pressure. This is Murray's abyssal anglefish. This is the angle, if you like. It's luminous, it drops it down in front of its mouth, someone comes along to investigate it, and then it snaps it up, and that's how it feeds. It's completely black where this thing lives. Discovered in 1887, also at the same time as the Challenger found the Mariana Trench deepest point, the Challenger Deep, and it's named after one of the founders of oceanography. His name there, Sir John Murray. That's how Murray anglefish got its name. We've known about that for a while. Also down there, over 8 kilometers below the surface of the sea, we have these snailfish. Kind of gelatinous. This is how they're able to withstand the pressure down there. Obviously, anything with a cavity in it that's living at these depths cannot survive. It's got to be completely solid and also somewhat compressible to be able to survive. And there's a group shown there in a remote submersible, 7.5 kilometers below the surface of the ocean. Now let's talk about some unusual animals. We all recognize this, don't we? Do they exist? Good. What an intelligent audience I have today. This is the tuatara. We find these in New Zealand. This is not a reptile. It looks like a reptile, but it's not. It diverged from them quite a while ago. About 250 million years ago, it diverged from snakes and lizards. It's the only creature left in its class. It's a living fossil. It's been around for 240 million years. It has a third eye, which we think is detection of ultraviolet. It is a very slow-moving creature. It may decide to move from one side of its enclosure to the other side of its enclosure after many, many hours. We had the pleasure of holding one when we were there. Now, what's unusual about this, and climate change is causing a real problem for this, is it lays its eggs in the ground, and depending on the temperature of the ground, that is the sex of the hatchling. And those are the temperatures up on the screen there. I'm not dancing, the ship's moving. 20 degrees, we get 80% female. 21 degrees, it's equal. And 22 degrees, it's 80% male. There's only a few females left. And New Zealand is trying very hard to keep this animal in existence through a breeding program. They do live long, so we've got lots of time to do it. Their lifespan's up to 200 years. Their population, 60,000 to 100,000 sounds good, but of that, there's a very small percentage of females left out there, and because of this very strange temperature effect. This is the aardwolf, not to be confused with a wolf. In fact, it's not a canid. It's not part of the dog family, if you like wolves and coyotes and jackals. It's actually related to the hyena. It does have canine teeth. It uses it for defense. But what's really fascinating about this creature is its main diet is insects. And it has a long, sticky tongue, like an anteater, to eat insects. Nocturnal, so you're not likely to see one during the day, because they only come out at night. This is the axolotls, the Mexican walking fish. It's a type of salamander. What's fascinating about this creature is, although it's not very big, its genome is 10 times larger than ours. So that's a very complicated genome. And maybe that is related to the fact that this creature can regenerate lost limbs. Now, wouldn't that be nice? If you chopped your arm off, you could regenerate it after a while. Those can. Unfortunately, as you see, they're critically endangered, so they're on the verge of extinction. This speaks for itself. This is the spider crab, the largest arthropod. And that's a normal-sized person holding it, so that's an absolutely enormous crab. This is the star-nosed mole. You're going to have nightmares tonight, having seen this. It lives underground, and it holds the record. It lives in North America, as the range map shows over on the right. It lives underground. It has 25,000 sensory receptors in that nose there that you'll wake up screaming at 2 o'clock this morning as one's coming to get you. But it won't take long, because it's one of the fastest eating mammals alive. It can sense its food and consume it in 120 milliseconds. Less than a second. It's just as well we don't have many of those upstairs in the ocean view, isn't it? There'd be no food left. It'd be gone in a flash. This is the purple frog. You find it in India, again, in a very localized area. So, of course, when you're in such a localized area, there's a problem. It can go extinct. It spends all but 2 weeks underground, and it only really comes up for mating purposes. It was found in 1918, but wasn't finally recognized for what it was until some years later. It does look peculiar. You wouldn't think that was a frog, would you, looking at it straight away? I said these were unusual. You're walking along and suddenly a snake glides past you, because there are some snakes that can glide, and we find them mostly in Indonesia, as the range map shows you over on the right. There's 5 species. Fortunately, if they did land on you and bite you, they're mildly venomous, so you're not going to die. But nonetheless, when you're walking around that place, you want to be looking for stuff up there. Now let's go to some real extremes about where things can live, that you might not think it's absolutely possible that they could do this. So these are called extremophiles, and they're broken down into various categories, and there are more categories than what I've listed up here, but just to let you know what some of these categories are. And I'll go through examples of each of these as we move forward. So this is a thermophile. This is the Sahara desert ant. And it's very hot in the Sahara. It can get extremely hot on the ground. They can sustain a body temperature of 50 degrees centigrade. 52 degrees will kill them. But the outside environment can be as hot as 70 degrees centigrade. So really dangerous for them to come out. But when they do come out, they can survive for some time out there. How do they do this? They have certain proteins that will absorb the heat shock that's happening to their bodies. And that's how they're able to survive. They only come out for short periods. They can do 10 minutes at a time, and those heat shock proteins will keep them safe. Halophile. In extreme saltwater content, we only find bacteria. So anything from 20 to 30%, then it's only bacteria that can survive. But shown over on the right, we have an unusual creature. Only 2 of these really are on the planet. I'll show you the next one. on the next slide. And this is the North Ronaldsay sheep, and it's located up here off the north of Scotland on an island. And their diet is 80% seaweed, which is very salty. They're able to deal with this. They've evolved to deal with this. And the reason they did was something happened on this island that created a dike. It isolated the sheep on the seashore, and they evolved in this area over about 5,000 years. So their diet's very different from normal sheep. And in fact, they can process copper in a very efficient way compared to normal sheep from the seaweed, which they need. They need the copper, such that a normal diet containing copper will poison them because they'll overdose on it. This is another halophile. Some of us have seen this. This is the marine iguana in the Galapagos. And immediately after this, in Connect or Engage, I can't remember which, I'm giving a short 30-minute talk about Darwin, the Galapagos, and what we saw when we went there. So lots more pictures like this. These creatures have evolved to be able to take the salt out of the water they're ingesting and sneeze it out, as shown in the picture, so they can actually get rid of the salt. This is a psychophile. This can photosynthesize well below freezing at -24. There's an example shown over on the right. That's in Alberta, Canada, where it does get cold. And of course, one of the reasons they can do this is they got some kind of antifreeze within their cell structure, and their cell membranes are much more fluid, so they don't freeze. But they're all small creatures. This is the only true insect that lives in Antarctica. And over on the right, for those of you who are too young, cover your eyes because they're mating. They can survive down to -15 degrees. They are so well adapted to cold temperatures that the larva cannot survive if it warms up much above 0. 10 degrees, in fact, will kill the larva of these insects that live in Antarctica. They're not very big, only about 6 millimeters long. This is the most resilient creature that we know about. This is a tardigrade. For those of you who have been watching some of the science fiction shows on TV, this was quite heavily featured on one of the shows that I saw. Discovered in 1773, so we've known about this for a while. They're not very big, only up to about 1.5 millimeters, and you can see some pictures of them here. They are found everywhere. There'll be a whole bunch in this room, somewhere. Over 1,000 species, and they can withstand pretty much everything. And this is the list of things they can withstand, even outer space. They can survive in that for a while, and another couple of pictures of what they look like. They're quite radiation resilient too. Let's talk about the venomous and the poisonous, because those are scary things. This is the fierce snake. Oh my God, I don't know how he did this. He picked these things up like this. A fierce snake. Look at the toxicity of this thing up there. The venom from one bite is enough to kill over 100 people. And the neurotoxins in this thing are incredible. There's even an enzyme in there to increase the toxicity of the nasty toxins it's already got. Has a venomous snake. This is the box jellyfish. 51 species, spread over 2 orders and 8 families. They're not all dangerous, but they're hard to see. As you can see from the picture over on the right, they're fairly translucent. They have enough, well, that particular one that I'm showing with its 3 meters tentacles has enough toxin in it to kill 60 people. It's just one of those tentacles. So again, not something you want to be swimming up against. This is the bullet ant. You'll find it in South America, down here. That's where it is. Very painful sting. Feels like being shot, apparently, from people that have had it. And the local people in Brazil, the Sato Maui, use it as an initiation rite for young men. What they do with the ant is they put them in gloves, sort of soporific, so they're asleep when the gloves are put on. And you see an example of a person wearing one of the gloves there. And it will bite them, sting them. And the initiation is they have to keep this on for 5 minutes. And by the time they've finished, their whole arm's paralyzed. Takes a few days to do it. Well, you think the initiation rite would be satisfactory having done that, but no, they have to do it up to 20 times. Go figure. This is the poison dart frog. We got the golden poison frog over on the right. Not all of the 179 species are dangerous, but there's enough toxin in the skin of that frog to kill up to 20 people. Heart failure is the cause of that. Now, interestingly, with these frogs, with their poisonous skin, they have poisonous skin because of what they eat. There are insects that provide toxin to the golden frog, also to some birds. The bird that's shown there in the right also has toxin on its feathers. But we don't know exactly what it is they eat that provides the toxin. If you take a golden poison frog and you keep it in captivity on a sort of normal diet, they lose their toxicity. They're not poisonous anymore. We're familiar with this creature, the platypus. Some of you may know this, but the males have a venomous spike, a spur on the hind legs, and apparently morphine does not help if you get stuck with one of these things. Females don't have it, just the male. This is the blue-ringed octopus. It has a venomous bite. The venom is not in the tentacles, it's in the bite. And that's got enough to kill 26 people. And you can see how big it is. It's not particularly big, but very toxic indeed. It's got tetrodotoxin, which is 1,000 times more deadly than cyanide. If you get bitten by it, basically you suffocate because you can't breathe. If you can be put on a ventilator, maybe your life can be saved. If you can get through the first 24 hours, you're probably going to be all right. These are cone snails. These are known as the cigarette snails because if you get stung by one of these, you've got time for a cigarette. And then you're dead. These are the assassin caterpillars. There is a whole bunch of assassin caterpillars here on a tree, and you could see they're hard to see. So you could come along and touch that tree, and you could get a nasty sting from that. They inject you with an anti-blood clotting agent, so essentially you bleed to death. About 500 deaths are reported annually from people getting hit by this in South America. What about appearance? This is the geoduck. Enough to be said, right? You can eat them. This is the ugliest, as voted in a poll, found in New Zealand and Australia. It lives deep. It's a gelatinous body, so when it comes up, it basically decompresses, and now you're looking at the ugliest fish around. That is the blobfish. These are pyrosomes. These are groups of zooids that live together, as shown in the picture down below. They can be up to 18 meters long. Sometimes they're bioluminescent. They will rise and fall with sunlight, and they can travel as much as 760 meters in a day through the water column. The mantis shrimp, most unusual, very complex eyes. Each eye is actually divided into 3 sections, and within those 3 sections they've got different photoreceptors. We've got 3 color receptors in our eyes. They've got up to 16. So they don't have the brain to interpret the color, they have the organs to interpret the color. This is what their spectrum looks like. Up above you see the human spectrum. Down below you can see what this shrimp can see. It goes down into the ultraviolet and almost up into the infrared. So they've got a really wide range of vision, the mantis shrimp. This is the blue galcus. It's a sea slug, and it feeds on Portuguese man-of-war. As you know, the Portuguese man-of-war is a deadly jellyfish. This is able to feed on it. It is able to utilize the poison to protect itself from other creatures. So it stores those sting cells. It's also a hermaphrodite, meaning it can breed with itself. This is the ocean sunfish, the heaviest bony fish. You see a diver next to it over here. There's the sunfish. There's 4 species of that, and you find them all over the world. So that's the largest bony fish. This is the thorny devil, found in Australia, in the range map where the green is. That's where you find it. It's got a false head, so things attacking it go for the head. It's the false head. They are spiny, and interestingly, those spines are useful for collecting water. The dew will condense out on the spines. There are rivulets in there, allowing the water to be collected from the spines and taken into the body. It's one way it collects water in a very dry environment from the dew getting in. It eats ants mostly. This is a tree kangaroo, and it's endemic only in a very small part of Indonesia there. They live up for about 14 years. And they do something very unusual. It's a very hot climate there. The way they cool themselves is they lick their arms, and then the saliva evaporates and it gives them a cooling effect on their arms. So that is an unusual way of correcting their body temperature or keeping it constant. This is the Gelada, also in a very small area of Africa. So it's endangered, of course. And what's very interesting about this is it mostly eats grass. You associate these with eating fruit or even some meat, and they're also very intelligent. We have identified 30 unique calls amongst the Gelada that mean things. The picture in the top right is showing a male. The redder, the better. He is now very attractive to the female, so he would be a good mate for the females. This is the pink iguana, location endemic. It's only found on Wolf Volcano in Isabella Island, only on one volcano in the Galapagos. And as you can see, we've known about it for not that long, only 2009. It is the earliest part of the divergence of things on the Galapagos that we found. It diverged from other iguana about 5.7 million years ago. So it ends up being pink. Critically endangered. This is the rolling stone toad, endemic to Guyana in South America. You can see the size of it on somebody's hand. And one of the ways it defends itself is, this is how it gets its name, it rolls away. It's very light, so it doesn't get hurt. Don't try that at home. You'd think that would hurt, right? All the way down. Ouch. Well, at least it was a water landing, but even so, it wouldn't have hurt itself, because that's what it does. This is the cassowary, the most dangerous bird. Look at the claws. It can disembowel you with one swipe. Solitary bird in Australia, very dangerous. Now, what lives here on us? You definitely aren't going to sleep tonight. We are an ecosystem to other creatures. Over on the left, the inhabitants of your navel. Please don't look right now. Over on the right, this is a face mite. You've got lots of them. Please don't try and rub them off, because you won't. You're a walking petri dish. This is a Demodex mite over on the left. There's 11 classifications of creatures that live on our body. So this little part up here is expanded down here. These are all the things that live on our body, and the color in the little pie charts is showing you the percentage of them around and on your body. So that's outside the body that we've got these things. What about within? Well, within we've got at least 10,000 microbial species living within us, and they actually do help. They help us digest food and extract nutrients. So they're not bad for you. And in fact, if you got rid of them all, you might actually be in trouble. So don't attempt to do that either. This is what we find within. These are the categories of what's living within us. And there are 3 domains of life. that we provide a host to, and they're very small, of course. There was a study done to try and figure out how much of this stuff was in our body. And so this used 242 volunteers, both male and female, to see what we could find within the human body. And in a typically 91 kilo person, there's anywhere up to almost 3 kilos of bacteria. So that's anywhere from 1 to 3% in our body. There was another paper that came out some time ago saying that human cells were actually outnumbered by a factor of 10. There was all these other things that outnumbered our own cells by a factor of 10. This has been refined. It's certainly not as bad as that. It's more like 1.3 to 1. So for every cell you've got 1.3 microbial cells that belong to something else that's not part of your body but is in and within your body. And that brings me to the end of Extreme Life. And as I said, dedicated to Steve Irwin. Such a shame that we lost him at such an early point in his life. Thank you very much. I will be doing Galapagos in about half